sharing the screen. I'm opening up the chat. So, all right. I just did this up in my office during the break, so I hope I got everything correct. We have our three packages again. The model, the view, and the controller. The interesting part is maybe, let's use kind of like red maybe, that we have an interface here. So you can take a look at how interfaces look in UML. It looks like a class, but you write interface inside of these strange little thingies on top. If you have a good tool, well, that will be automatic for you. If you don't, well, then you have to work around in some way. We have actually a new arrow, this one. It's called realization. And using this arrow, we show that the player type in the controller realizes the dice game observer interface. And maybe, as you remember, this was the observer mechanism. And we have actually two new associations here. We have the dice game got 3 dices, so we have 3 associations here instead of 2. And, well, we have the names on them, as usual. And we have the observers that we put in a list. And while it could be correct to, well, the dice game actually has a list that is a template class that contains objects that realize the dice game observer interface. Well, that is more of an implementation detail, so you just say that the dice game contains lots of them. And, well, we could choose to put them in a list or in an array or whatnot, a linked list, a tree, or whatever, during the implementation. You can see it from the point of view that when you make a blueprint for a house, you don't specify exactly where all the nails are going to be, because that would, well, maybe not be so good. Would take a lot of time, and, well, the carpenters will probably do as they like anyway. So you can, of course, leave details up to implementation, and if a design decision is not that super important, then you can just push it to implementation. And we have this abstract class. Can you see the notation for making it abstract? The difference between a concrete class, the English or Swedish console, and the console. Can you spot the difference? No, probably not, because this name is in italics. And this is not maybe the best of choices in UML to have this, because when you write something by hand, well, it's really hard to, okay, now I'm going to write in italics with a leaning. So actually, I often prefer to use kind of like write abstract up here instead over the class name, because that is mostly visible. And, well, I don't know if you saw that it was italics. You can probably see it if you look at it really, really closely, but it's not that easy. So not the best choice of notation, I think, but that is how it is. And, well, we can work around it and live with it. So watch out for that. Questions on the class diagram? No? Good. I will post it on the course homepage also. You can do an image from this, right? So, yeah, we did the observer, and there are, of course, lots of different ways to structure your applications in different manners. Model view controller is one example. Another one that you come across is layers or tiers, and this is very, very common in computer science and software development. You structure things as a collection of layers, from a more specific layer to a more generic layer. And you see this over and over again. And you can also think about this as inside my model class. Well, there, inside of it, maybe I would like to have a layered structure. So you have more specific layers and more generic layers inside of the model class. So just because that we have decided on a generic architecture for our logic view, model view controller, we can continue structuring our classes if we need to inside of these packages. And layers is a very common way of doing this. And what we would like to have is we would like to have changes to be confined. That is, if we do a change in one part, this should not ripple through. So if we change the database or if we change the platform, everything should not need to be changed. We would like to have reusable, exchangeable parts. So if we have a platform, we should be able to use this platform layer and exchange it for another platform layer if we change the underlying hardware platform, for example. We have parts that are decomposable into coherent subparts, so we can find, okay, these classes or what we have, they all kind of like collaborate to do one thing. So it is good to confine them and put them in a separate place. And we need to divide work strictly. Maybe we have experts in some case. So while, for example, agile processes often empathize that you should not divide work by experts, but rather you should have a small group that does one feature from beginning to end. Sometimes you would like to use experts. And then you should use them in the most efficient way possible and letting them work with that in which they are experts. And the solution is to divide the system, as I said, in coherent layers of responsibility and let higher layers be more specific and let them depend on more generic lower layers. We find this over and over again, actually, when we code. You probably have used some kind of libraries. We use the console, for example, in our little dice game. You could see this as, well, we build functionality by layers. We use the console to do a more specific task, in our case, the dice game. We have the console that is more generic, and we have probably other layers beneath it that we don't see because we only see the console API or functionality. A classic example here is the three-tier layer, layered structure of many web applications. So we, at the most specific part in the hardware, we have the client computer, the box and processor and screen and mouse and or whatnot. We have a server, and we have a database server. So the database server will run fine without the web server. The web server will run fine without clients. But clients can't function without the server, and the server can't function without the database. And looking at it from a process perspective, on the client computer, we have a web browser that executes and runs. And on the web server, we could have Apache, for example, that runs the server process. And on the database server, we could have MySQL running. So we have a physical layering, we have a process layering, and we can have a development layering also. That we could think about presentation. And to run presentation in the web browser, we use JavaScript and HTML. Those are the technologies that we decide to use in this layer. And for the logic part, we use PHP, for example, that we can run in Apache. And we can define a RESTful API between the presentation and the logic. And for data storage, we use PDO and SQL. And this also gives you an example on that we need to look at a system from different points of view. We focus on the logical view. We could do model view controller in this part to separate things better. But from the hardware standpoint, we have a client computers, and we have a server, and we have a database server. And we need to think about, okay, internet, how fast is that communication? If we have performance requirements, for example. How much data can we push between the server and the client computers? And we maybe have a faster connection between the web server and the database server. Should they be on the same computer, maybe? Decisions that we need to make. We need to, for example, decide, okay, the web browser, how is it going to communicate with the server? Well, we need good security, so we're going to use the HTTPS protocol. So thinking about your system from different points of view is a good thing. And this is an example of this 4+1 view. You can see the hardware, you can see the processes, and you can see the development view. And you will come across layers in almost everything you do. So, finally, software components. Software components are a way to reuse and build software using already designed and implemented and tested and deployed cohesive reusable modules. This is quite a broad definition, and many things can be regarded as a component. For example, a web service, a web API can be regarded as a component because it runs on a server somewhere and you can access it in some way. So it is something that is more than just copy-paste reuse. We reuse actually something that is executing, something that is bigger. Could be maybe hundreds and thousands of types, classes involved in providing this service that we want. So often we have special technologies for this. Java Beans, DCOM, Corba are standards that are used on different platforms and in different ways. The general idea is that you should be able to write a component in like any language, and you should deploy this component in a component environment. And when you build your system, you say, well, I would like to have components that do this and do that and do this, and they should be connected in this way, and then I get my result, and maybe I just write a little bit of code to do that. And as you deploy more and more components, maybe you get better components, and these should be automatically used because they do the same things as the other components, but just better. So there have been some interesting work in that part. We're going to look at a very, very simple component technology on the Windows platform, DLL files. So we could structure our code, our program, and we could make a dynamic link library. And this could be shipped to other developers as a component that does something, and they can use it. And it can be also shipped to customers or clients that, okay, if you use this component, this will happen. If you use another component, something else will happen. So this is a way of structuring and building our systems also. So let's go for an example and see actually that this is kind of neat. So we will actually do this in C#. And I have prepared a little bit, so So we started by making a solution. We named it component dice game, and now we're going to rename this one to console, and we are going to add actually a new component here, and it will be in the simplest form of a class library, a DLL. And this is very Windows specific, but you should be able to do this in most other languages also. So we added a new project. This will actually be the one that provides the component for us. So we will remove this that we got there, and we will just take the model from here. Copy. Paste it in there. Add the files. And I will actually remove this third dice because I have some prepared code that it does not play with this nicely, I think. So we are just reverting to the old rules, so to speak. We can hopefully compile this. I think maybe we should change the namespace. So yeah, it seems to be compiling at least. Yep. So in this console, we will add the view and the controller. view. And we will copy these also, so it's taken from here, view. And the controller. Something like that, I think, and we should add them. Right, and we need to do one final thing here and also make some changes. We need to add actually a reference. So we must tell the development environment that, okay, this project is dependent on this other project. So we do that. Otherwise, we can't use the stuff in it. Possibly that is actually it. We have some main stuff. I think it will look something like this. So and this is also something that is interesting now. Now that we have put the dice game model in a separate project, we need to show what is visible outside this component. And so we can increase encapsulation this way, because we must now explicitly tell that this is a public class. So we must tell the component that, okay, this is okay to use from the outside. So we can increase encapsulation here also. Yeah, and the same thing about this interface. We can define what is inside and what is outside of this component. So what we get now is, if we look at what is this system is made out of, we can see that we have the executable here. But we can't run this as it is, because it's missing a component. Unhandled exception, system IO file not found, could not load file, assembly dice game model. blah, 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 blah. And this resides here now. This is the component, the dice game model component. Now it works, because it has access to the component. And this also means that we can change this component. And at our clients, we can just change the component that has changed. So if we change the rules here, for example, it should be 3. We can just build this one. And we can take this new component. Up. Wrong. One. Yes, that was kind of like incredible. So this way we can build our system using pre-packaged, already compiled, running software. And we can change things at the client computer, so to speak, in the user's computer, instead of having to recompile and build things and then ship things. And we could even, when we develop our software, well, maybe we have lots of dice game models already prepared. And when a customer comes in, well, okay, we take this user interface and we take these game rules, and well, here's your new software. So we can compose things this way instead. And a third kind of like neat thing, I think this is the loaded DLL, so I will close it, is that we can, of course, add other user interfaces more easily also. So add new project. And this is something I also have prepared, because it would take a lot of time to fix this otherwise. And I probably have not the exact same names here. And we must add also the reference, if you remember. Add subscriber. So we now have a graphical user interface instead. We can play. 1. I can't win. 2. So this way we can structure our projects into components. We have one component that is for the console user interface, one that is for the game rules, and one that is for the Windows Presentation Foundation stuff. And this is kind of neat, I think at least. Maybe we should revert to the good rules there. Questions? Do you think it was cool that we could just add a graphical user interface to our game rules without changing them? This is exactly what we want. Now, the VPF project is not model view controller. It's just a big fat view user interface, but it's at least model view separation. And this is often some kind of trade-off when you use a big framework like VPF. Well, you kind of like buy in to their way of doing things, and you need to work with that. You can't decide on your own, really, when you kind of like take a big framework. You must play by their rules, and this is, of course, something that you need to take into consideration when opting for a framework or a big library like this. Anyway, we can also see that now we have the old model here, so now it's also time to really manage what components are where and what have we shipped to whom. So versioning and version control becomes even more important here. And we could take this executable file and we could put it here. And if we kind of like, let's remove it. This won't work. It's missing the component, just like the console missed the component. But we can add it. And it works. And it should be the new rule. So 1. Yay. Questions? These kinds of simple components that I've been talking about now, they are often available in the language of your choice. Some way of packaging more than just a type into a single file to be reused. Java has jar files, for example, that work in a similar way. DLLs on the Windows platform, well, that's maybe just the simplest form of component technology, almost that it could not be regarded as a component technology. But it will suffice as an example of more of a high-level reuse that can be achieved by using good architecture and using good coding practices. All right, I will be posting this on the GitHub account as usual. I will also be posting a link for the final hand-in for workshop number 1, so that you can hand that in when you feel ready. And you do that in your groups, so it will look just like the first form you submitted. Any questions? Nothing? Great. I think we covered a lot of ground today. Next week we will be focusing more on detailed design, more on applying patterns, and well, we will start a new example. So I hope this was the last DICE game for this year at least. So bye for now.